Alright, let's wrap up this log unit with the finale on natural log. Again, the rules are all the same for logs, so let's try expanding this. So this means we're going to take this and use the laws of logs to expand this. So this is going to be 3 natural log of x. Okay, so that 3 was the exponent here, but now it's going to the front. And then plus 4 natural log x minus 2, and then minus, alright, this is the natural log of x minus 5. Now that's the square root of x minus 5. That's like the power of a half, so we can write 1/2. Okay, let's try this one. So this is going to be 2 natural log of x plus 1/5 natural log x plus 7 minus natural log of x minus the natural log of x minus 5 and the power of a half. We'll go in the front like that. Okay. Alright, in condensing them, same idea. We're going to take this one natural log and put this all together. So I see there's some being added, some divided. We'll have x to the 4. We'll have x squared minus 4 cubed. And we'll have x plus 5. Now you could go square root here, or you can go to the power of a half. It doesn't matter. Okay, so notice this means we're dividing. That's why it's going on the bottom. And the positive means we're multiplying, so it goes on the top. Okay, so 1 log here, it's going to be x plus 9 to the power of 2/5 times x cubed. Oops, no, I don't want it there. I want it here. Even though it's not written, we've got like brackets like this. So this is x minus 8 to the power of a half, and m plus 1 to the power of 6. Okay, by the way, looking at this, if you preferred, you could do this. I'm going to show you. So we could have written m plus 1 in the numerator and gone to the power of -6, right? But what happens when you have a -6 in the exponent? Well, this would become positive by moving it on the bottom. That's why we have m plus 6 on the bottom like that. Okay? Alright, solving. So what kind of question is this? This is a log on one side of the equation. So what do we do when there's log on one side of the equation? We can change to exponential form. Alright, except that we first of all have to get rid of this. Let's move that to the front. And before we go any further, hopefully you recognize this is 1. So now we don't even have to change to exponential form, we just get x 7/5. Okay, same idea here. We're going to take this and we're going to move it to the front, right? Well, you can't, because it's not in log form yet. Alright, if this was like that, then we can move it to the front, but it's not. So we have to do something else. Well, what kind of equation is this? Do you notice these bases can't be made equal? So let's take the log of both sides. And we're going to take the log of both sides, but I'm going to take the natural log of both sides because I see the e there. Okay, so I took the log of both sides. Now what? Well, now I can move this to the front, to the coefficient, so I get alright, I get that, and remember I told you how often this was going to show up? The natural log of e, that's 1. So I can just forget about it because multiplying by 1 doesn't change anything. Okay, and now what kind of situation do we have here? We have logs on both sides. What do we do when there are logs on both sides? Well, if we have log of something equals log of something, those two somethings equal each other. So then I get this, and I get x is half. Okay, I'll give you a second to think about this one. What do you think you need to do here? By the way, when you're thinking about it, if you want to do some studying, a good idea would be to go back and retry these questions before you see me do them. See if you remember what to do. Okay, because the notes basically cover all the types. Okay, so what's going on here? Okay, that allows me to put 3x plus 7 as a coefficient. Again, you see that's 1. So you have the natural log of 6. So what's x going to be? Well, it's going to be this. So we're going to go natural log of 6, take away 7, divided by 3. This is negative 1736. You should definitely try that. How did I get here? Okay. Your calculator, when you put log in, is going to open up a bracket. Make sure you close it there. Okay. Make sure you also know that this has to really have brackets around it like that. Okay, last one. Again, this is one where the bases are different, so we're going to take the natural log of both sides. This allows me to take the coefficient. And then this is almost the same question as the last one. Okay, pause it for a second, try to do this one on your own. Okay, and I have 0.991. Okay, that's right. Natural log 7 plus 4 divided by 6. Okay, that's good. Okay, and before we wrap it up, we're just going to quickly do one more type of okay, and remember I told you that you have to be able to use logs in any kind of word problem. This is actually a pretty common one. Okay, this is for natural growth and decay. Natural growth and decay, think of this, you ever heard of rabbits multiplying? Okay, you know, if there's 2 rabbits, suddenly there's 4, then there's 8, then there's 16, and you have an exponential graph like this. Okay. When we have natural growth and decay, we have what we call exponential growth. Okay, where does this kind of happen? Anywhere in nature. So you're going to see this with, you know, what's called a half-life. You're going to see this with things like bacteria, and you have to kind of know that this is the formula that you're going to use. Okay, now if it's not on your formula sheet, normally they have to give you the formula. In this case, I see bacteria, okay, and natural growth. That's why I know I'm using this formula. Okay, sometimes instead of RT, it's also RN, same idea. Okay, A is the final amount, P is the initial amount, rate is R, and time. And the time always will match the rate. You don't have to worry about any kind of conversion there usually. Okay, so this says the population of bacteria is 20,000. So we start with 20,000 bacteria. and it's increasing at a rate of 0.37, and it says find the population after 25 minutes. Again, you don't have to change that to hours or years, just use the unit that it's given. Okay, so we're just going to type that straight into the calculator. We get 20,000 times E, and now notice if your calculator, it should have opened up brackets there. So leave the brackets open and go 0.37 times 25. And this gives you a pretty big number. Okay, I would just make sure that you put this as one number. Okay, so it grows really quickly. But that's a really easy question. You probably didn't need logs for that. Well, you didn't need logs for that. You just needed to recognize what E was. It gets a little trickier with this type, and this is a really common type of question. Okay, it says a concentration is reduced. So if you look at the formula, okay, the original amount is decimal 0.03, and it gets reduced to decimal 0.01. Okay, and we're supposed to find the rate. So we don't know R. We know that this happened in 4 minutes. Okay, so how do we solve for R? Well, we've seen these kinds of questions. You're first going to divide by 0.03 on both sides. So you get now 0.01 over 0.03. You can put that in the calculator. That's going to give you a repeating decimal, so just leave it. Okay, so we get this, and you know that anytime you have an exponent that's a variable, you're going to take the log of both sides. So you're going to take the log of 0.1 over 0.03, and if I take the log here, I can put the exponent in front, and again this is going to be just 1. So how do I get R? I'm going to divide by 4. Okay, so let's put that in the calculator. So 0.01 divided by 0.03 divided by 4. So R is negative 0.27465 ... Leave this in the calculator. Important. Leave this in the calculator. Okay, because it asks us to say, alright, this was A, to find the rate. We're now supposed to do B. Okay, what is B? Well, B says how much would be left in 10 minutes. Okay, so the amount, again, we're starting with 0.03. We now know what the rate is. Okay, we're going to use this number when we take the calculator, and we're supposed to say time is 10. Okay, so let's try this. 0.03 times E, and now when it says the power of, put answer times 10. So super small number. And if we're supposed to round to 2 decimals, which we usually are, we'll go with that. Okay? Alright, one last question I'm going to show you. This has to do with something that is also quite common. The idea of a half-life. You're going to see this in science a lot. Okay, half-life means how long it takes to decay so that only half is remaining. So you think of some thing here, if there were 10 units, when its half-life is done, there will only be 5 units of the same item. Okay, so the key here is that you have to understand that it's half-life. Half-life tells you, why can't I erase here now? Half-life tells you only half is left. Okay, so the half-life is 14.9 hours. Sodium, that 24 is actually a red herring. You don't need that. Okay, so let's write this. A hospital buys 40 grams. we know that the rate of decay is 14.9 hours. And it says how much will remain after 48 hours. Well, hang on a second. We don't know what the rate is actually. Okay, well we do. We know the rate is 14.9 to decrease the 40 to half as much. So you're going to put 20 there. Really, anytime you have a Half-Life question, how much you start with is irrelevant. You could have easily just put 2 and 1, because we'll only have half left. It's going to give you the same answer. Okay? But in this case, we'll go from 40 to 20. And we need to know what that rate is, because 14.9 is the time, not the rate. Okay? So let's solve this. We'll divide by 40. So 20 divided by 40 is this. And then we'll take the natural log of both sides. Now 20 divided by 40, I'm just going to put 0.5. I get 14.9 R, and then natural log of E, which again cancels out. So R is the natural log of 0.5 divided by 14.9. So the rate is negative. By the way, what does a negative rate mean? Well, it means it's decreasing. It's decaying. There's going to be less of it. Okay, so now that we have the rate, we want to know how much is remaining after 48 hours. Okay, and so we'll leave that. That would be the second part. So now we would put time as 48 hours to figure out how much A is. And then C would be, well, if we want to know how much time it takes for 1 milligram to be left, okay, you would start by doing it this way. Okay, we'll leave those questions. Not too worried about those right now. Now I have some homework for you. Yeah, I got a lot of homework for you. This is a big unit. It's important. Okay, make sure you get this stuff done. Work hard, ask questions. You will for sure get stumped. Okay? Let me know if you have questions.